Good afternoon, everybody. Welcome. This is a 10, 15-minute talk about virtualizing big data. I'm from VMware. My name is Justin Murray. I'm in technical marketing at VMware in Palo Alto, so the other side of the country. What I'd like to spend 10 minutes or 15 or so with you is what is the potential and what is the desire, and how would you actually virtualize if you went about it. So agenda very briefly would be, why would you virtualize Hadoop or Spark? And we've been testing Spark heavily in our labs in Palo Alto, and we feel quite comfortable that you can virtualize not just Spark, but machine learning and actually deep learning. All of these things can be virtualized. If you think about it, they're virtualized in the public cloud already. Those are full of virtual machines anyway. So I'm going to give you two reference architectures that we see commonly among our customer base, and I'm going to show you a couple of graphs of performance, in particular performance of machine learning and Spark algorithms running on virtual machines on VMware. And then I'm going to give you some references, and feel free to talk to me afterwards about the content. So why virtualize Hadoop? It seems like a sort of a crazy thing to do. After all, with Hadoop, we're trying to squeeze the last few ounces of performance out of our machines. But in fact, virtualizing Hadoop is very beneficial to it, and you're going to see graphs that show virtualized, it actually runs as well as and slightly better than native bare metal. And how could that be? Well, it has to do with VMware optimizing the architecture, the NUMA architecture of a Hadoop environment, and I'll say more about that later. That's a performance point, but the main reasons people want to virtualize are nobody has just one version of Spark and Hadoop at any one time. If you're like me, you're getting an email once a month from a Hadoop vendor telling you there's the latest version, 5.12 is available. I'm using 5.10 right now. When you have two versions of something like that, or three versions in your enterprise, putting these things into virtual machines and separating them that way is the best way to get multi-tenancy of the environment. So that's a big reason people choose to virtualize. They also want to separate out their developers from their testing people, from their production people, and virtualizing is the inherent way to do that. But a lot of people really don't want to dedicate a full set of hardware to just one Hadoop cluster anymore. You have these 10 boxes here in your data center, and if you dedicate them to one cluster, that's it for their lifetime. You don't get to use them for anything else. Virtualization is a way to get around that. And a lot of customers come to us and say, I'm an IT department, I serve the business users, and what I want to do is provide Hadoop clusters as a service to my end users. I want to provide it on the fly, Hadoop and Spark clusters. What you're going to see are some results of Spark running on top of Cloudera, but we're also running Spark standalone. And recently VMware announced a project with Amazon Web Services, and you can actually use VMware on Amazon now as a public cloud as well. So just delving into the architecture for a second, I won't talk about this very much detail. This is a classic yarn architecture that you'll recognize. You've got masters on the left-hand side and workers in the middle here, and there are many hundreds of workers in a big cluster. There are 5 or 6 masters on the left-hand side. What does it mean to virtualize this? Do I have to change my Hadoop architecture or my Spark architecture if I virtualize? The answer is really, it's fairly simple. I take everything that used to be on its own physical machine and place it into a virtual machine. The red boxes are virtual machines here. So each of the workers, which contain the data node and the node manager, goes into a virtual machine, and those virtual machines might be 4 of them to a server or 2 of them to a server. We almost never recommend you do one virtual machine to a server, because that doesn't get you the NUMA benefits that I referred to earlier, and I'll say more about that. We might want to treat these virtual machines as special cases. These are masters, they must be alive for a long time, so we might want to put them on expensive servers and put the workers on cheaper servers. But there's absolutely no problem at all with having 4 copies of the worker code running in separated virtual machines on the same physical server. And we do that all the time, and we actually get the best performance out of 4 virtual machines per server. So I can give you lots of reference architecture documentation on that later on. So what's the benefit, really? Virtual machines give you the ability to have heterogeneous versions of the operating system, heterogeneous versions of the Cloudera software or Hortonworks software, allow you to do fault isolation, so one cluster doesn't affect another cluster. You can do that by separating them off into something we call resource pools. You have fault resiliency. You have actually very good performance when you virtualize. Performance can be up to 10% better on VMware than it would be on bare metal. That's an outrageous claim, but I'm going to show you the types of testing we've done to prove that. So a couple of real-world architectures, and these are fairly technical architectures now. I don't want you to be fazed by them. I can give you some more paperwork, technical white papers on them, but these are architectures that we come across very frequently. So these are 2 virtual machines now running on VMware hypervisor here, and these are the direct attached storage devices that typically you would be using if you were doing this all on physical. So the first lesson is exactly the same hardware that you would have used for a physical Hadoop cluster can now support 2 copies, not just 1 copy, of the worker node from the same cluster or from different clusters. Now, ignore the complexity involved here. All I'm doing here is saying I'm taking these disks and dedicating them to this virtual machine, and taking this set of disks and dedicating them completely to the leftmost virtual machine. So effectively, I've achieved in virtualization what I would have done at the physical level, which is these disks are used by one and only virtual machine, only one virtual machine, and they have no interference from its partner that's living on the same server. This is the direct attached storage model of deploying VMware on or Hadoop on VMware. It's completely traditional. It doesn't differ very much at all from your standard way of doing it, and actually we co-wrote a reference architecture with Cloudera that describes this. So this model is completely supported by Cloudera, as well as ourselves. And we wrote that back in CDH 5.3 time, which tells you we've been doing this now for about 5 years or so. So that's one architecture for virtualizing. That's in quite common use, actually, among our customers. A second one is separating out the compute from the data. You're hearing a lot about S3 as a mechanism for storing data. You're hearing a lot about other protocols for storing data. The whole point is you want to be able to flex your compute power without having to touch your data power. Or you want to be able to increase your data fundamentals without changing your compute. And this is an architecture for doing exactly that. And we invented this, and this is also supported by Cloudera. I would call this the data compute separation model. Here, the virtual machines are not doing any of the data handling. All of the data handling is being done across the network by a device that understands HDFS. Now, this could equally well be S3 or NFS or some other protocol that's capable of feeding data to these data nodes. These node managers. So this is a virtualized cluster just for compute. And the benefit you get from this is you can have more virtual machines on the fly that just contain node managers and don't have any data node process in them. In other words, they're data free. They're just reading their data across this fast network to get it in for processing and sending it back to HDFS again. So a classic model here is an Isilon server. If you have an Isilon server, that thing understands HDFS, and HDFS protocols are obeyed across this interface here. My point, though, is really there are a choice of architectures for you to deploy virtualization on. It's not just one architecture. In the future, this will be S3 as well. And it could even be S3 on Amazon with the virtual machines running on VMware Cloud on AWS, which is effectively running VMware on AWS hardware. That's what that is. So if we add into that some shared storage here on the bottom left, then shared storage is what a lot of the values of VMware, like being able to move virtual machines from one host server to another, that sort of vMotion or live migration capability is entirely a function of shared storage. So if your HDFS data is remote from your virtual machines, and these virtual machines only know it through a reference on the network, then they're capable of moving around on the system just as they would have done in regular VMware, regular vSphere. So this is a tremendous architecture that was actually adopted by one of our major systems integrators, and they do this as a hosted service for some of our customers. And this too has a document from Cloudera describing it, so nothing I'm talking about is in any way risky here. This is a vetted architecture by the Cloudera folks whom we worked with on this. You can get these documents from me, by the way. If you send me an email, I'll send these documents as well as other performance documents to you. And there is a statement of support from Cloudera on their website, so if anybody were to say to you, I can't run my Hadoop Cloudera on VMware, it's not allowed, it actually is supported. There's a support statement there. So the interesting point in my talk comes up in performance. And I want you to focus in on the contrast between the yellow bars and the gray bars. The gray bars represent physical systems. So in this case, it was actually 13 physical servers. In the yellow case, there were 4 virtual machines running on each of those servers. In the gray case, there was 1 copy running on the native operating system. And you can see here that for Spark Random Forest, pretty contemporary workload, Logistic Regression showed the same results. So this is a machine learning algorithm here, Random Forest. 4 virtual machines came in faster than the physical gray bars, by an order of about 10% faster. The reason for it is because the hypervisor is placing those virtual machines down into the NUMA architecture in a better way than physical Linux would do. It's not crossing NUMA boundaries in the same way that processes on physical Linux would do. And that's the reason we're seeing lower completion times, i.e. better performance on the yellow bars than on the gray bars. Gray bars represent physical, yellow bars represent 4 virtual machines on each of these servers. So that result is at least a year old. We've done this twice now in a series of rigorous performance tests. And you can see that also in the case of Logistic Regression, another machine learning. This was using MLlib from the Spark libraries. And here, 4 virtual machines per server is again faster than native, all due to NUMA and networking parameters in the vSphere technology. So here's my set of references. I don't expect you to take these down. You can have these slides if you're interested in them. One reference I would like you to remember is vmware.com/big-data. vmware.com/big-data. All of these references will be available there. Or you can also send me an email. My email is jmurray@vmware.com. jmurray@vmware.com. And I'll send these things to you. There's at least four years of performance work done in these papers. Finally then, my conclusions are Hadoop and Spark workloads and machine learning and even deep learning workloads work very well on vSphere. vSphere runs on in-house servers, but it also runs on AWS servers in Amazon data centers. That last part is called VMware Cloud on AWS. So you can run the same workload on in-house vSphere as you would on public cloud vSphere. Various performance studies have shown that you don't lose anything by doing this. In fact, you stand a good chance of gaining performance from doing that. We have best practice guidelines for you. There are reference architectures from Cloudera and from ourselves. And then you can follow some design patterns that we've laid out, like separating compute from data. So simplified management, better efficiency, good performance, and above all, the agility that comes from not dedicating all of your hardware to just one Hadoop cluster. These are the benefits you get from virtualizing Hadoop. come and talk to us in the booth over there. We're next door to Cloudera. We're more than happy to talk to you. We have some of the demos that performance work that I showed you here, and we can show you that to you. And thank you.